Hello, this is Radio Geek, and today for you I have something a little different. It's not a radio kit, or a radio actually. It's a kit, and what I did is I ordered something from this website called Tindy, and there's a seller on there called the Makersbox, and he was selling these Joule Thieves on there. And I bought this some time ago, so I'm not sure if he's still selling them, but there are others that are selling them as well. Basically, it's just a kit of parts, and if you're not familiar with what a Joule Thief is, what it is usually it's a AA battery or a AAA battery that's pretty much depleted for any useful purposes, such as powering a radio or a flashlight or something like that. So it's basically a spent battery. And there's a circuit that you can build that basically what it does is it takes the voltage from that spent AA or AAA battery and it boosts it up. It's a boost converter, and it boosts that voltage up high enough that it will drive an LED. So basically you can have this battery that is pretty much useless, and you can use it to power a little LED, which will make a little flashlight. And it's all powered by a battery that has been pretty much depleted. Now you could put a regular full brand new battery in there and it'd work just as well, but it's kind of a waste of a good battery when you can power this up with a spent battery. So anyway, when I ordered the kit, I have the kit here and the kit of parts, and we'll get that bag opened here in just a minute. Also, they sent me a little cute 3D printed frog. I thought that was kind of funny, and I believe the sticker also came from them as well. It's Hacker.io, so you can stick this on your laptop or your forehead or wherever. So let's open this little bag of parts and see what we get. It also has a URL on the bag which will go to the instructions on building the kit, so they don't have to print a bunch of paper. You can just send you there to the website and you can view it on screen, or you can print it out if you want to. Now, I thought it was very unique and just kind of a neat thing for educational purpose, but if you look at the board here, it shows you where the components go, obviously, and then you have your choice of populating the battery terminals depending upon if you want it to be powered by AA's or AAA batteries. But on the opposite side, the solder side, I guess, where you're doing all your soldering, it has the schematic. So I thought that was kind of cool. So when you're done, you can look at the back and there's the schematic, and if you've got an issue, you can check different things. It's a pretty simple circuit. There's not a whole lot to it, but I thought that was kind of a cool idea. It's rounded. It's nicely rounded. It's a nice quality circuit board. So yeah, it's very well laid out, very well marked, very nice. Okay, so what do you get in the kit? You get everything you need. You get a couple of these battery terminals for your AA or AAA, depending on how you have it spaced on the board. This is a like jumbo white LED, which is kind of cool too. You have the little transistor here, which does the high-speed switching that generates the boost in conjunction with a inductor. Now they give you the core and some wire, and you do have to wind your own inductor, but the instructions are pretty good, and it's not super critical. If you miss a turn or add a turn, it's still going to work, so not a big deal. And then one resistor, so not much to it. Oh yeah, and the on-off switch as well. So not much to it as far as parts are concerned. So I'm going to go ahead and put this guy together, and then we'll come back and check it out and see how it works. Okay, so I thought I'd show you what they were talking about here as far as the coil winding goes. It says that insert both wires about halfway through the coil. Now these are separate wires, they're not twisted together, they're just separate wires. If they are twisted, you need to untwist them, so they're just separate wires running parallel to each other. And then I'm just gonna say that's about halfway, and then it says continue to wrapping the wires through it from both sides until you have 7 to 9 loops. Pull the wires as tight as possible. And then it says cut the leads so that you have about 1/2 to 1 inch remaining. So they've given you plenty of wire to do this. So I'm going to try to zoom in here. There we go. So we've got this wire here, and it's just going through there once, and we're just going to loop it through again, both wires. Pull it tight as we can. I know my hands are getting in the way. It's hard to film this. So then you have your coil like this, and you just keep going until you get your 9 turns. So you get 1 done, and then you just loop it through again, and then pull it tight, making sure that you don't get them twisted together or entangled in each other. And we'll get that tight there. You might have to play with it a little bit as far as to get it tight and to kind of get it the way you want it to look, but basically you're going to have 7 to 9 turns, basically is what it says. So you can kind of do this side and work your way up the coil here, around and around and around, and then the other wire you just loop it through, and you'll be going here up to here. So basically you just keep looping this side and keep looping that side. You can go back and forth or do one side first and the other side, but you should end up with almost all the way around here. You'll have 7 to 9 turns if you count them, and it counts as a turn in pairs. So you got the white, like in this case it's a white and green, so that's 2 turns I've done so far. So just 2 turns is all I've got done so far. We'll continue with that until we get 7 to 9 turns, and we'll see what that looks like. Okay, so this is what I ended up with here. I think I've got 8 or 9 turns there, and that's kind of what it looks like when you're done. Just take your time. If you don't like how it looks, just unwind it and start over. Just make sure both ends are at the equal length, and just get one going around, and then do one on the other side, and then just make sure that your 2 different colors are parallel with each other and they don't get crisscrossed, and you should be fine. Like I say, I don't think this is super critical. If it's anything that resembles that or or anything else, I think you'll be fine. So now we're ready to get this installed on the board. Now that we have it wound, this is the most difficult part, and it's not really that difficult. And if you make a mistake, you can unwind it and do it all over again. So you're not going to hurt anything if you wind it up and it doesn't look like you think it should. Just keep trying, take your time, and you should be fine. Okay, so now I've got it all assembled and ready to check out. Now I left my inductor a little bit proud, a little bit high, just so that I can see or show you the board itself. As you can see, the way the board is laid out, the silk screen shows the winding of the coil. So basically that winding in the coil, the same color wire has to be there. So like on this side is green, and on the opposite side, or on this side, the back side I guess, it's green as well. So you can see the silk screen on the board for the coil. I can better show you on the back there, I guess, but basically from this point, let me get something to point with here. Basically from this point to this point has to be the same color wire, and from this point to this point has to be the same color wires. Those are the little windings, okay? So mine green is here, and it goes wind, 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 green. And over here it's white, winding, 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 white over there. So these have to be the same color, and that has to be the same color. If you do that, it should be fine. So I've got the inductor wound and put in there, and all the other components. And I got the switch. I've got this spent battery first. But we do that. And our battery has a voltage of 1.36 volts. So it's kind of weak. It's not like dead, but it's weak. So it will work on a much lower voltage than that, but that'll be what our reference is here. And so we'll put the battery in here. Make sure you get the polarity correct. And we've got our switch here. Okay, and whoa, look at that! It lights up. That's pretty bright. That's pretty cool. So now you can take your old spent batteries that you have no use for and put them in one of these, and you can have this to you know, find your way through the dark if there's a power outage, or keep yourself from stubbing your toe, or whatever. But anyway, I just thought I'd show you this Joule Thief kit, and it's a pretty nice kit. It's pretty easy to build. I'd say it's a good first kit to build, maybe as a project with a child or a young adult that maybe not have any soldering experience. Like I say, the hardest part's probably winding that inductor, and it's not really that hard if you just take your time and watch what you're doing. You'll be just fine. But anyway, it's from a website called Tindie, Tindie, and the seller of this one is the Makersbox. So until next time, this is the Radio Geek.